A plane flies horizontally at an altitude of 5 kilometers and passes directly over a tracking telescope on the ground. When the angle of elevation is pi over 4, this angle is decreasing at a rate of pi over 6 radians per minute. How fast is the plane traveling at that time? And then round your answer to 2 decimal places. First thing we want to do is make sure we can draw a picture. Okay, so again here it's saying that the plane flies horizontally. So we're going to draw a horizontal line. Okay, and it's saying that the plane is flying horizontally at an altitude of 5 kilometers. So now we're going to say, okay, well, that is the height. So there's the height of the plane. Okay, now the next step is to create an angle. So this angle, here's the plane. So what is that angle down here? Okay, so now let's go ahead and then label our picture. So we know that this represents the value of x. Okay, and we know that it's saying that it has an altitude of 5 kilometers. So we know that this represents 5 kilometers. And then up here is where our plane is. Okay, so what it's saying here is that it's creating this angle theta. Okay, so therefore here is our picture. Okay, so it says the angle of elevation is pi over 4. So let's write out the given information. So we know that theta is equal to pi over 4. Okay, so that's the angle of elevation, and then it's saying that this angle is decreasing at a rate of pi over 6 radians per minute. Well, that represents, if it's decreasing, we know it's going to be a negative value, and the rate is considered that slope. So that means that we know that d theta with respect to time is going to equal that negative pi over 6, and that's radians per minute. And so what we want to look for is what is dx over dt. So this is what we want to be able to solve. Okay. So now we need to use our picture to determine this. So using our picture, let's do the following. Okay, well, what do we know about particular sides? Well, this represents the adjacent side. And this represents the opposite. So we need to think about, okay, well, what does that tell us? We know that to find the cotangent of theta, well, that is equal to the adjacent side over the opposite, which equals what? Well, we know that the adjacent is going to be x over 5, and therefore we can rewrite this as 1/5 x. Okay, so now that we determine that, okay, now we know that the cotangent of theta is going to equal 1/5 x. So that tells us the following. We know that the cotangent of theta is going to equal 1/5 x. Okay, so now the next step is we want to take the derivative of this equation. So in order to take the derivative of this equation, okay, we know that in order to take the derivative of the cotangent of theta, we know that that's going to give us negative cosecant squared of theta. Now recall that we also need to use the chain rule here. So we need to take the derivative of theta. So this is the outside function, and the inside, we're taking the derivative of theta with respect to time. So therefore, we're going to say times the derivative of theta or with respect to t. And then this is now going to equal now the derivative of the right side. So the derivative of 1/5 x is going to be 1/5. And then using the chain rule, again, this is times the derivative of x with respect to t again, which is time. So now from step 2, we want to fill in the information for step 4. So what I mean by that is, okay, we know that theta is equal to pi over 4, and we know that d theta over dt is equal to negative pi over 6. So that's this right here. Okay, and again, what we're looking for is dx over dt. So let's go ahead and substitute our information for step 5. So we know that we have negative cosecant squared of theta. Theta is pi over 4 times d theta over dt, which is negative pi over 6, and that's equal to 1/5 times dx over dt. So we're looking for dx over dt. Okay. So in order to solve for dx over dt, we want to first find what is the cosecant of pi over 4. So let's go ahead and solve that over here. So we want to find what is the cosecant of pi over 4. Well, recall that that's the same thing as 1 over the sine of pi over 4. Okay, so remember that we're dealing with a 45 degree triangle, 45, 45, 90. So we have 1, 1, and then the square root of 2. All right? So we know that this is going to equal 1 over 1 divided by the square root of 2, which is equal to the square root of 2 over 1. Okay? And now what we have to do is we need to square both sides. So that means that we're now going to square the cosecant squared in order to find out what that's going to equal, which is going to equal the square of the square root of 2 over 1. And so that's going to equal 2. So now we can go ahead and then evaluate this equation. So this is going to be the negative 2 times negative pi over 6, and that's equal to 1/5 times dx over dt. Okay, so the next thing here is we're going to go ahead and multiply that out. So a negative times a negative, 2 pi over 6 reduces to pi over 3, which is equal to 1/5 times dx over dt. And so now what we're going to do is we're going to multiply both sides by 5. So we end up with 5 pi over 3, which is equal to, let me erase that, should be dx over dt. Okay, so now we just need to go ahead and then solve, but let's make sure that we understand what dx represents and what dt represents. Okay, well, if you take a look here, we know that it's saying here that it's an altitude of kilometers. So that means that dx is going to represent kilometers, and then time is in minutes. So we know that this is in minutes. So that means we have 5 pi over 3 kilometers per minute. Or if we wanted to simplify this a little further, we would do the following. And that's because it's asking us to round our answer to 2 decimal places. So therefore, we would take 5 pi, divide that by 3, and rounding that to 2 decimal places gives us 5.24. So we would say 5.24 kilometers per minute.